What if I told you that the universe has an edge? Not a wall, not a boundary you could touch, but a horizon. A point beyond which nothing we will ever build, ever launch, or ever imagine can reach. And what lies beyond that edge is one of the most unsettling questions in all of science. Let's start with something that sounds simple. The universe is approximately 13.8 billion years old, which means light has had 13.8 billion years to travel since the Big Bang. So the observable universe should be a sphere about 13.8 billion light-years in radius. Except it isn't, because the universe has been expanding the entire time. Space itself has been stretching. And because of that expansion, the most distant objects we can observe are actually about 46 billion light-years away. That is the cosmic horizon, the edge of what we can ever see. But here is where it gets strange. That horizon is not the edge of the universe. It is the edge of our observable universe. The universe itself almost certainly extends far beyond that boundary. How far? We do not know. Some models suggest it extends at least 250 times further than what we can observe. Other models suggest it is infinite. Truly, literally infinite. Extending forever in all directions with no edge at all. And beyond our observable horizon, right now, there are almost certainly other galaxies, other stars, other planets, places where if anyone lives there, they look out at their own cosmic horizon and see a completely different slice of the universe than we do. They cannot see us. We cannot see them. We are forever separated by the expansion of space itself. Not by distance, by the speed of light being finite in an accelerating universe. Now let's talk about what's actually at that horizon. What happens at the very edge of what we can observe? The answer is deeply strange. As we look further and further out into space, we are also looking further and further back in time. Light takes time to travel. The light reaching our telescopes from a galaxy 10 billion light-years away left that galaxy 10 billion years ago. We are seeing it as it was when the universe was young. At the very edge of our observable universe, we see the cosmic microwave background, the oldest light in existence, the faint afterglow of the Big Bang itself, emitted 380,000 years after the universe began. Beyond that, we cannot see. Not because there's nothing there, but because the universe wasn't transparent before that point. The early universe was so hot and dense that light couldn't travel freely. There is a wall of the past we cannot see through. But here is what we can deduce about what lies beyond. The universe, as far as we can tell, is remarkably uniform. The same physics, the same ratio of matter to dark matter, the same fundamental constants. Whether we look in any direction, the large-scale structure of the cosmos looks the same. This suggests that whatever exists beyond our horizon looks much like what exists within it. More galaxies, more stars, more planets, the same cosmic web of filaments and voids, stretching on, just forever unreachable. But it gets stranger still. Our universe is not just expanding, it is accelerating. Something we call dark energy, a property of space itself that we do not fully understand, is pushing everything apart faster and faster. Which means that galaxies currently inside our observable universe are slowly moving beyond our horizon, disappearing forever. Right now, as you listen to this, galaxies are crossing our cosmic horizon and vanishing from the observable universe, not because they're being destroyed, but because space between us and them is expanding faster than light can cross it. They become, in every meaningful physical sense, unreachable, unknowable, gone. Let's put some numbers to this. Currently, there are roughly 2 trillion galaxies within our observable universe. each containing hundreds of billions of stars. In about 2 billion years, the accelerating expansion will begin to noticeably thin out the cosmic neighborhood. Distant galaxy clusters will start to blur and redshift beyond detection. In 100 billion years, most galaxies beyond our local group, the cluster of galaxies containing the Milky Way, will have receded beyond the horizon. Future astronomers will look out and see a universe that appears to contain only a handful of galaxies. They will have no observational evidence that 2 trillion others ever existed. They will think the universe is small, lonely, nearly empty. They will be wrong, but they will have no way to know that. In 1 trillion years, if intelligent life still exists anywhere, they will look out at the sky and see almost nothing. The expansion will have carried every other galaxy beyond the cosmic horizon. They will be alone in a universe that appears to contain only their own galaxy. They will have no way of knowing that billions of other galaxies once existed and disappeared beyond the horizon. There is something even more unsettling hiding in all of this. If the expansion continues to accelerate, and every observation we have suggests it will, then eventually the expansion will become so extreme that it tears apart not just the space between galaxies, but between stars, between planets, between atoms themselves. This is called the Big Rip, a theoretical end state where dark energy grows so powerful that it overwhelms every other force in the universe. In this scenario, roughly 22 billion years from now, galaxies are torn apart. Then, about 60 million years before the end, solar systems disintegrate. Then, 30 minutes before the final moment, planets are shredded. Then, in the last fraction of a second, atoms themselves are ripped apart, the very fabric of matter, dissolved by the expansion of space. Not all physicists believe the Big Rip will happen. It depends on the exact nature of dark energy, which we do not yet understand well enough to say for certain, but it is a genuine scientific possibility, and it illustrates just how strange and violent the far future of the universe might be. Even if the Big Rip doesn't happen, the universe's long-term future is bleak by any human measure. Stars will run out of fuel. One by one, over trillions of years, every star in every galaxy will exhaust its hydrogen, expand, cool, and die. The last red dwarf stars will flicker out roughly 100 trillion years from now. After that comes the degenerate era, the universe populated only by stellar remnants, white dwarfs, neutron stars, black holes, slowly cooling in absolute darkness. Then, over unimaginable timescales, even the protons that make up ordinary matter may decay. The remnants of stars dissolving into radiation and lighter particles. What remains are black holes, growing slowly through quantum processes then, over timescales so vast they make the current age of the universe look like a single heartbeat, evaporating through Hawking radiation. The last black hole will evaporate in approximately 10 to the power of 100 years. Written out, that number has 100 zeros. After that, nothing. A cold, dark, empty universe. Maximum entropy. No energy gradients, no complexity, no possibility of anything happening ever again. This is the heat death, the final state, the universe winding down to absolute stillness. We are lucky to live in this moment. This brief window in cosmic history where we can still see the universe's full richness, where we can still look out and see 10,000 galaxies in a patch of sky the size of a grain of sand held at arm's length. That view is temporary. The stars above you tonight are not permanent fixtures. They are a phase. A brief, brilliant, improbable phase in a universe that began in a singularity, expanded through darkness, ignited into light, and will eventually over timescales beyond all comprehension, go dark again. The edge of the universe is not just a place. It is a clock, and it is ticking. But before it runs out, we are here, looking up, wondering, asking questions that the universe itself cannot answer. And that perhaps is the most extraordinary thing of all.